Good afternoon, everyone. Apologize for the short delay with the start. Now we're already technically ready, so I'll just start now with the presentation. What you see is the final presentation of the project, which we've done for the European Copper Institute in the last couple of months, and we have submitted also a comprehensive report. Now the presentation just summarizes the results. The idea of the whole project was to study a couple of regulatory models for network regulation, electricity network regulations in Europe, and then also to focus explicitly on the regulatory incentive for network losses, in this case especially for distribution losses. And just to put this whole work in the context of efficient incentives, or incentives for to encourage the installation of efficient equipment, in this case efficient distribution transformers. So the work is kind of combination of more or less economic work for the regulatory environment in a couple of countries in Europe, plus also a bit application and also short cost-benefit analysis for distribution efficient transformers. So you see in the next slide, what you see here is the content of the presentation. We have 6 points to cover during this presentation. One is just shortly to introduce again the reason to have the economic regulation in the context also in this case of electricity networks. One is to say a couple of words about different regulatory models. There is a large variety of these models, starting from the classical rate of return regulation, and then just really going to more comprehensive models for incentive regulation. One is then just will continue with regulatory practice, not only the theoretical models, but also we'll study here in this case the application of these regulatory models in a couple of European countries. When I say a couple of European countries, we have here Germany, UK, we have also Norway, the Netherlands, and Spain. Then in point number 4 we'll continue with the specific focus on the distribution losses in terms of regulatory incentives and also regulatory experience in Europe. And then we want to focus a bit also on the incentive schemes in Spain, and just to see exactly how it works there, and just to put in the context of really again this focus on the efficient equipment, or equipment with for loss reduction in the distribution networks, in this case, as already said in the beginning, distribution transformers. And just to derive some conclusion on possible improvement also in general, what could be done just really to encourage the installation of such kind of equipment, or in the total context of the economic regulation. We will start with the first point. What you see here in this slide, rationale for economic regulation, is just the classical really ideas and the classical reasons why we have to regulate. I'm not planning now to explain the report. We explain also the reasons of this. Just again shortly, we have scale and scope economies, which is the typical economic reason to regulate. As you know, distribution and transmission also remain regulated even if the electricity market is deregulated. The typical reason is scale and scope economies. Also we have high initial sunk cost in these networks. And also the last point, what you see here, the market failure, what we put here, is not really typical for the electricity network, but also is also interesting, or let's say typical rationale for regulation. Usually it is related to so-called externalities. In this case also there are external effects which are not really explicitly internalized, and in many cases a regulator has to do something just really to ensure the proper outcome. That's why also externality could be the reason for regulation. In practical terms, as already said, electricity networks remain regulated, and that's why the regulatory policy towards this regulation is essential to encourage the efficiency increase in the network. We'll see afterwards what means efficiency increase and how really it is practically achieved by different regulators. When we start talking about different regulatory models, we have to distinguish probably two big groups of models. One is the so-called rate of return regulation, and one is a group of models which actually could be really integrated under one, which is called incentive regulation. The first one, rate of return regulation, what you see is the very simplified formula. That is slide number 3. The formula is written here, just I'll point it out now. And in this case, just the regulator or regulators allow revenue which includes the cost of service to provide the regulated service in this case, and allowed rate of return. And this usually the cost of service in this case, if you go a bit deeper, you can see that it includes all really necessary operating and maintenance expenditures plus depreciation, and as already said, we have this return component which have to really give rate of return on the assets necessary to provide the regulated service. Usually the rate of return, that's really the most traditional rate of, type of regulation. It is implemented with pretty frequent regulatory reviews, not really with long regulatory periods, and then it requires a bit more really intensive checks of the cost situation of the companies to arrive at the allowed revenue. There have been a number really discussions in on academic and practical level what are the benefits and also the drawbacks of the rate of return regulation. On one side, you can say in very simple way that it's transparent and also pretty straightforward to implement, to apply. On the other side, however, in terms of efficiency properties, rate of return have been strongly criticized in the literature, but also by practitioners, that they don't achieve really the required or expected efficiency increase. And usually there is another group of critics, the so-called overcapitalization, because the rate of return is given on the assets which really acquired by the companies to provide the regulated service. It can really go, or can cause or can lead to overcapitalization and overinvestments in the companies. Because probably of this critical point, some regulators started at the beginning of the 80s in Europe, but also in outside of Europe, experimenting first on the academic level, then afterwards really these regulators start experimenting on practical level with different types of models which could be integrated under one big name, the so-called incentive regulation. Now we go to the next slide, and what you can see, for example, is a very again simplified example of the so-called cap models. What is the major difference of these cap models is that differently from rate of return regulation, they just extend the regulatory periods. It means, when we say extend, it means that the time between the two regulatory reviews, two regulatory checks, is longer than 3, usually actually 5 years. So we have in different countries different actually time, but usually you can see a range between 3 to 5 years of this period. So also that's the first difference. The second one is that the price path or revenue path, which actually really is allowed by the regulator for the regulated service, for example in this case could be electricity distribution, is fixed in advance using a specific formula, which could be simple one as you see here in this slide on the right side, but could be also pretty comprehensive and long one, as you have seen probably in this report if you have a look at our report. If you see this simple formula, which is actually really the more or less the essential, I would say really the backbone of the cap regulation, you can see that in this case the price could be also revenue here, is really linked to the development of the inflation. In this case we just use a consumer price index, and also efficiency increase factor, which is called X factor in this case. So what is actually done is that the price or revenue develops with the inflation, also minus the expected productivity or efficiency increase of the regulated companies. So you can see also this one, this formula simply represented on the graph below. So the initial level is here. You can see the price level, could be also revenue depending what kind of really cap we're using. is there, and you can see there is a red line which goes from left to right down, and this red line on the right side is called RPI minus X line. It means that's where the regulator really expect or require actually to the revenue or price will develop. So it means it's more or less the projected trajectory of the revenue or price. And if the company the companies manage to perform better, to overperform, it means better than the expected revenue or price by the regulator, so they can achieve gains which are called efficiency gains. And these efficiency gains are here given also with the yellow color in this graph. So everything what is below the red line and during the time of the regulatory period, and it's part of the company's performance, in this case the companies managed to perform better than expected, it is called efficiency gain. And the reason for these two models, actually revenue and price caps, have been the simple one that if the companies have the chance to go really for longer regulatory period, as already explained, 3 to 5 years, and they know in advance what is expected, so they can really mobilize all their efficiency potentials and just start really to improve the efficiency, knowing well in advance that all efficiency gains achieved during the price control period will remain with them. So it means more or less the model tried to encourage the companies to continue or to increase their efficiency and construction efficiency of operation also, depending how really the models work, and in this case to achieve these efficiency gains which will stay with the companies at least for this regulatory period. It could be also that the regulator allows the so-called efficiency carry forward, so it means that part of these efficiency gains will continue to stay with the company to be retained also in the next price control period. We'll go to the next slide now, and we'll explain a bit what kind of models exist. I mean, we can say that cap and revenue, the revenue and price cap is already set, and this revenue and price cap could be also very different. You'll see also in our report we explained different types of revenue caps and the price caps. But even in this case, if you say that there is a revenue or price cap, they could be very differently implemented, and sometimes also in the practice you can see the same word which is called revenue cap, but there are completely different interpretation of this revenue and price cap. So just we try to more or less to summarize in our report and to explain the major differences, and we grouped these actually two models, this revenue or price cap, in two big groups. One is called the so-called building block models, and one is called the sort of TOTEX models. When we say TOTEX, it means total expenditures. And this group actually is based more or less on the practical evidences. We observe such kind of, let's say, building block models in some European countries. In other, we observe the so-called TOTEX models. I'll explain later what we mean here. The building block models, we can say that's a cap, again, cap models, but they're implemented as a coupled caps. It means that usually the allowed revenue or price is not really completely decoupled from the cost, but more or less coupled to the expected efficient cost development during the price control period. And as you know that in the incentive regulation, almost all regulators try in one or another form to apply the so-called efficiency analysis or benchmarking. What it could be observed in the building block models is that they apply the efficiency analysis on the controllable OPEX. So it means this operating cost which could be controlled by the companies. Of course, they also check for the capital expenditures, but it is not really integrated analysis. So it means usually the capital expenditures are also afterward checked and again projected in the regulatory period. Such kind of models, for like building blocks, applied in the United Kingdom, in UK, Great Britain, also in Ireland, and also in Australia. So we see that the regulator and the companies, after consultation, arrived at projections of the allowed revenue, including operating cost, depreciation, return, but also sometimes losses, depending how the loss arrangements works, in the next regulatory period, which is, as already said, usually 3, but also I would say 5 years. In UK and Australia it is 5 years. In this case there are really projected revenue which is capped, that's why it's called revenue cap, but it is coupled to the efficient cost expected. So it means we explicitly take into consideration the development of the cost in the expected regulatory period. Differently from these models, we have the so-called TOTEX approach, which is usually implemented as a decoupled caps. It means again revenue cap, but without really projecting the cost in the regulatory period, but more or less starting from one specific initial level, usually last historic achievement, and then just really putting a formula which is not really coupled to expected cost development, but just really extrapolating the existing historic level towards in the future, as already said, using automatic formula. Could be also a different approach, the so-called yardstick regulation. In this case we completely decouple the revenue from the cost situation, and just we try to couple the revenue allowed for the specific company which is regulated on something exogenous for the company. Could be, for example, the average performance of the other companies in the sector or in the sample. This decoupled caps, so TOTEX, is typically, for example, very good example for this model is Germany, which really implemented from the 1st of January this year this TOTEX approach. When you just really starting, for example, for 2009, the revenue will include 2006 initial cost position, the so-called initial revenue in Germany, and that will just really index this initial revenue with a specific long formula, which will really arrive at the allowed level of the revenue in every year of the regulatory period, which is 5 years. In this case, these models usually work again with benchmarking, but the benchmarking, differently from the building blocks, is a bit more comprehensive, because the benchmarking includes also not only operating expenditures, but tries to integrate also the capital expenditures. So in this case we have a total cost benchmarking. It means we compare companies with other companies, not only on the operating cost level, but also incorporating the depreciation in return. It means the capital expenditures. And because the companies have different structure of the assets with different age, sometimes also with they have different capitalization policy. If you go for international benchmarking, but also depreciation profile could be different, there is a need to standardize the capex. So it means there is a need a bit more to think and work how to really achieve a standard capex. It means standardized capex in order to provide, or in order to carry out robust benchmarking. It means benchmarking which can ensure really good comparability between the capex positions of the companies in the sample. We go to the next slide. Just shortly, as already mentioned, yardstick regulation. Now we're on slide number 6. Is an interesting model. It means in this case we decouple revenue from cost and couple the allowed revenue of the regulated company with probably the cost of prices in the industry. It is a good model in terms of efficiency properties. Something has been criticized that actually is not easy to implement. Also in the report we provide a couple of typical points why these difficulties. And one last point, which actually is also very important in this context when we're talking about economic regulation in general, but especially for electricity network, it is the quality of supply. And this discussion for quality of supply has become even much more important after the massive introduction in the Europe especially of the incentive regulation models. Because of the probably nature of incentives to reduce the cost, it has been always a fear or negative feeling. We can say that the quality can start suffering because of the strong reductions or strong incentives for cost reductions. That's why many regulators, actually almost all regulators in Europe, have supplementary but also pretty comprehensive schemes to support the quality of supply or to regulate the quality of supply. And these schemes can really incorporate or can include different components, starting with very simple public exposure. It means really publication of specific ratios, but also really analysis of the quality performance of the companies which are regulated, towards more comprehensive models, like for example using standards or even incentive schemes. You have still probably noticed in the report that also many regulators, like for example in UK but also in Spain, they apply incentive schemes. It means revenue is not only coupled with cost or efficiency, but you can see also a link between the allowed revenue and also the quality. And when we say quality, just probably shortly to be clear what we're talking about in this case, according to the European regulators, there is a common understanding that we have three quality parameters. One quality parameter is probably the most important one, is the so-called reliability. It means to provide service which actually is reliable. It means we have electricity, non-interruptible electricity supply, and continuous electricity supply. And the next two dimensions, the so-called commercial quality, which measures the quality of relationship between regulated companies and customers, and also the so-called product quality. For electricity case, product quality means technical quality. It means, for example, a couple of technical parameters like frequency stability, voltage stabilities, and also other to be ensured. Usually in the context of the discussion we have today, quality has been more or less, only the reliability has been really essential, because actually the reliability is directly related to the cost situation. When you have actually sustainable and good incentives for investments, usually quality, also reliability, can benefit also from these investments. We don't really follow more the topic quality in the work on this presentation, but also in the report. Just I wanted to say again that to mention that it's really essential to mention the topic quality, to discuss the topic quality, because incentive regulation without quality supply is probably difficult to be used in long term. That's why we say also in the report quality supply is imperative in the context of incentive regulation. And then just we'll continue with one also a very interesting topic. It is also called trade-off. It is slide number 7, trade-off between OPEX and CAPEX. What does it mean, trade-off between OPEX and CAPEX? It means that the regulator must establish balanced incentives on both sides, because if actually the incentives are unbalanced in terms of OPEX and CAPEX, and we'll see also discussion in this discussion afterwards in the context of efficient transformers, then the companies can go or can be encouraged to go for suboptimal choices. And there are different also options or different actually really cases for the suboptimal choices. In some cases, if the regulator has not established balanced incentives, the companies can prefer more CAPEX than OPEX, or just the opposite, depending how the regulatory incentives work, and not really just to have the proper right mix to use CAPEX and OPEX. In some other cases, even they can start reclassifying expenditures. For example, something which is probably more OPEX, like a maintenance scheme, to be put on the CAPEX side, and to be really actually balanced in the balance sheet, then as opposed to be expensed as an OPEX component. So it could be also again perverse incentive, because this reclassification is not necessary, but just the company go for that one if the regulator does not establish proper incentives. And then also, depending also how the regulation works, we can also have really incentives to delay investments, which can cause really risk on quality of supply. Sometimes we can also have an incentive to oversize investments and then to delay, to postpone, to defer them. All of these actually cases here which I listed are really not positive and negative, and can be avoided if the regulatory incentives are properly balanced. What you see is now on the slide number 8 again is what I explained, the topic quality, now a bit presented as a graph. We're talking about also called really optimal quality, and from the perspective of the regulator, which actually is really more or less representing the public perspective, optimal quality means to have minimal social cost. So it means when we say what is social cost, we have to see on one side is the cost of reliability. It means of upgrading the electricity grids continuously. So it means the cost of investing but also operating the grids. And on the other side is really the cost of damages. So it means of outages, cost of outages. In case we have more reliable grids, it means we have invested and the grid is more and more reliable, so we reduce the outage cost. And just the opposite, when we have less actually reliable grid, we have not invested too much, so we have lower cost of supply. In this case, we increase the outage cost. Of course, there must be optimum, more cost for reliability, for example, for investments, less outages cost, and just the opposite, less cost of reliability, more outage cost. In this case, there is an optimum, as already said, the optimum results from the points where we have total social cost minimized. And that's the point where the regulator wants to go, that's the point which the regulator wants to achieve with the whole regulatory schemes and arrangements. Just it means to establish the companies, to establish incentives for the companies, to encourage the companies to go for this optimal point. Slide number 9. Now we really just focus on one specific point, which is called network losses. And network losses are part actually of the network industries, because in technical terms, when you operate electricity grid, you have to incur some losses, network losses. And because the grids is already set regulated, then regulator has to start dealing also with network losses, because this is really part of the grid business. In terms of types of losses, we have different classification. You can say simple that we have the so-called technical losses, which are variable, which means losses which vary with the current, with the load of the network, and also fixed, the so-called iron losses, which are more or less independent on the utilization and the load of the network. Or we can have also the so-called commercial losses, which have non-technical nature and usually associated with stealing electricity, also, or really manipulating meters. These cases are not really technical. They are not actually really typical for all countries in Europe. So we have also countries where we have serious issues with commercial losses, like Central Eastern Europe, in some countries, especially Eastern Europe, and sometimes also Central. But we have countries like in many of the countries of the western part of the European Union, we don't have serious discussion or serious issues with the commercial losses. Nevertheless, also I have to mention the commercial losses, because all the regulators in the countries where the commercial losses are a problem have to address them, and there are a variety of also regulatory schemes how to address and incorporate the incentives for commercial loss reduction in also the allowed revenue or in the price control process. The next point actually is the so-called valuing of losses, because the regulator at the end is really interested to establish allowed revenue. It means money, and the physical allowance for losses, it means the gigawatt hours is not sufficient, so we have to convert really this gigawatt hours also in money. And this actually valuation has to be based on the cost of losses, so it means of the cost of electricity to provide additional energy to cover the electricity lost in the grid operation process, the electricity distribution process, or the electricity transportation process. Now, in this case is when we say the additional cost, usually the major component, and probably the most important one, is really the cost of generating electricity. Of course, we have to think also that must be also, or maybe, a need of additional transportation capacity to provide the electricity, for example, to the distribution grids. And also there are costs of environmental impact. For example, when we produce electricity and the price does not include all the cost of the environmental impact, this also could be, they have to be also integrated. Now, starting with actually all the three components, there are different models how the regulators can really address them. Some regulators can say we want really to model or to see exactly how the cost will work. But some regulators can say, if I have a reliable electricity market, I can also really use this market and just take the market price expected or really historic market price and value my losses. And the last point, which actually is really essential, we said regulators must deal with electricity losses or electricity network losses because they are part of the process. Now the question is how they do that. So do we have really different regulatory model for dealing also with electricity network losses? Yes, we have different models, and what you can see is one classification used by the UK regulator of GEM, and also widely adopted by many regulators also from other countries when they really address this issue. We can distinguish between three types of models which are typical for the network losses regulation. One is a so-called input-based scheme, which means that a regulator tries to establish really or to allow the cost of specific equipment and the cost after regulator has allowed the cost of this specific equipment for the losses, then regulator also has to put the proper allowance for electricity losses. It means to allow the percentage which is expected to be achieved by the company after the installation of this efficient equipment. Alternative regulator can also use output-based scheme, which means in this case they can say that's the level of losses which I want to see, percentage of gigawatt hours, and the company must really select the proper mix. It means in this case OPEX or CAPEX, investments or also operating measures, operating cost measures to achieve the expected really level. Minimum standard is a modification of the input-based scheme. In this case we just set really the standard expected without really checking how the equipment must be really used by the company, or what kind of equipment the company wants to purchase and also to require to be included in the regulatory asset base. It means to be recognized in the price control process. Slide number 10, you can see really the practical experiences in Europe, what kind of schemes now in Europe are used. In the report we've done a lot of analysis, and also in the report we've done supplementary analysis for additional countries. Actually we really reviewed or scrutinized the paper of ERGEC related to distribution losses, and then summarize the results in the paper. What you see in this table is a bit deeper, more deep analysis. Let's say we went a bit deeper for the price control schemes and the loss arrangements in 5 countries in Europe. So these are Germany, UK, Spain and Norway, plus Netherlands. All of these countries are using incentive regulations. All of these countries have already some forms of really regulation or encouraging efficiency, network loss reduction, and all these countries use in one or another form efficiency analysis, the so-called benchmarking, at different levels. What is interesting that sometimes there are differences in terms who is purchasing the electricity network losses. Is it really the network company, the network operator, or is it the supplier? In any cases, or the supplier, in this case you can see for example UK or Spain, even if the supplier is purchasing the network losses, again the the regulators using incentives for network loss reduction. Then the design of these incentives is a bit different, but again it exists, because just what is encouraged in these cases is the difference between the efficient and the actual losses, as opposed to the models where the network is purchasing losses. Then in this case the network operator, in this case usually the regulator put an allowance on the total losses, because the cost of total losses are with the network operator and not with the supplier. Slide number 11. Now we're starting with this the so-called simplified cost-benefit analysis. As Fernando explained in the introduction, the idea was not only to review the efficiency properties of different schemes for network regulation, especially in this case distribution network regulation in European Union, but also to see what could be interesting, what could be done in terms of, let's say, encouraging installation of loss reduction equipment. So that's why we have to develop kind of, let's say, framework in this report, how to deal with this analysis, what is actually really positive and what should be encouraged in this case by the regulator to be installed. And we actually are facing the typical investment problem. It means, does it make sense to go for kind of solution, in this case, for example, with installation of loss reduction equipment from the public, but also from the regulatory perspective, and at the end, of course, from the company's perspective, because the company must be incentivized by the regulator to go for this equipment. Yeah. What we actually try to do in this case in our report is really to go for simplified cost-benefit analysis. It means to try to measure the cost and the benefits of installation of this equipment. So when we say cost and benefits in this case, actually we are talking about incremental cost and incremental benefits. It means what we are trying to see is we have the dilemma as a company to go for new equipment, and we have also the dilemma to go for conventional or for, let's say, loss reduction equipment. Probably there are different parameters of this equipment, and just we try to measure what if we have to invest more. It means we have positive incremental investment, we have to spend money, and what we can expect actually is benefit. In this case, we have the benefit from loss savings in the next years. So in this case, we just try to measure dynamically. It means with discounting what is really the incremental investments, which will be the minus, it means the cost of the company, and then also on the other side the incremental benefit, it means the loss saving, which will be the plus, the benefit for the company. And then also to measure this, to put actually this analysis in the context of something, we just selected two types of transformer, and also after discussions and also support of the European Copper Institute, we you can see also in the report, it is called table 1. We use two types of transformers. It is 400 kilowatt ampere, 630 kilowatt ampere, with the specific parameters as indicated in our report. Just we try to measure the effect on these two transformers using one-time conventional and one-time efficient transformer. It means with loss reduction functions. We used also more or less average load factor of 63%. We tried to monetize also the loss savings in long term. So we done actually kind of price forecasting for the Spanish electricity market, a simplified one using unit commitment model. And then also we use discount rates just between 5 and 6% for this for this investment analysis purposes, just really to see what is going on in terms of, let's say, cost-benefit ratios. What you see in the next slides is some selected results. The first one is really the result for 400 kVA for 400 kilowatt ampere transformers. You see that we have two discounting rates, 5 and 6% here. And on the left side you see this column, which is really dark blue. It's the investment, or in the incremental investment. It means we have to pay more to install these transformers, but we can expect also for the future benefits. And these benefits really, you can see them on the horizontal axis. Every year they continue, and these benefits, as already said, they're resulting from the loss savings. It means the gigawatt hours which we can save with the installation of this equipment are just monetized by the expected market price. This market price actually established using the unit commitment model, more or less is cost-based plus 10% markup, just to really to account for market imperfections. And you can see also that we have two lines. One is with the 5% and one is of 6% on the discount rate. It's normal, then just because we try to do sensitivity analysis, and we can also in this case case, in any case, we can see that the result is somewhere 9 to 10 years. What means this 9 to 10 years in this graph is that is the dynamic payback period. So we need at least 9 to 10 years under these conditions of our modeling to really pay back for this investment. So we can say that after the 10 years, the society will start really getting the benefits from this investment. Of course, because the investment will live more than 10 years, it looks that it will be really reasonable investment. Of course, providing that the company decides to go, it means the company is encouraged via the regulatory arrangements to support this decision. It means to invest in this specific type of equipment. We can see now the next slide, number 13. It is the same actual analysis. Now we try to really extend the model with more sensitivities. In this case, we decided to provide, or just to carry out a sensitivity, which is really related to the investment cost or to the incremental investment. We just checked what will be plus minus 20%. It means to reduce or to increase the price differences between the two types of equipment. And as expected, if you of course increase the price difference, it means the more efficient equipment is more expensive, then the payback period is actually getting longer. So you can see the line which is down, just I'll point it now, it is this here, it is this one. So it means in this case we have more expensive efficient equipment, we have longer payback period. Alternatively, if you just have price decrease on the investment side, on the investment cost, it means we can purchase the transformers cheaper. So in this case the price difference is less, so we invest less in incremental investment, and in this case we can also really enjoy quicker recovery, so shorter payback period. That's really the graph here, what you see on the left side. Alternatively, you can also run additional sensitivity scenarios using different types of price assumption. So as you remember, incremental investment is a measure for us for the cost of the company to invest in more efficient equipment, but the companies can enjoy also benefits, and these benefits result from the loss savings multiplied with the price. And depending how the price can develop or will develop in the future, these benefits can also vary. For example, if the price is increasing or is expected to increase in the future, we can enjoy higher benefits because we are saving losses, and in this case also we are saving cost for losses to purchase electricity to cover losses. Oppositely, if the price really is going down or is expected to go down, in this case will be the opposite effect. What you can see here is also two parallel lines. The major line is again the dark blue, and then on the right side we have also this line, which is the line when actually the price is really lower, minus 10% than the reference price in the reference scenario. And then we have the left line, or the line on the left side, when we have actually higher price, in this case higher benefits, and of course shorter payback period. Shortly on the price control in Spain, we can we have here revenue caps. The regulatory period is 5 years. We have a really comprehensive regulatory formula which integrates a couple of variables, including efficiency, inflation. We have also a quantity term. We have a quality incentive scheme within the price control. So it means that we have a number really of elements of this regulatory formula. The allowed revenue in general terms as other regulatory regimes include the operation and maintenance cost, also called OPEX, the depreciation and return, it means the capital cost component, the capital return of the assets necessary to provide distribution service. Interestingly, interesting in this price control is that we don't have explicit CapEx projections in the regulatory period, but we have a really quantitative quantity term, which actually couples the allowed revenue with the expected distributed electricity. So it means if we have more electricity distributed, we can expect as a company also higher allowed revenue. We have also loss adjustment term. It means we have a loss incentive, network loss incentive scheme, when we actually, the regulator is using the classical model using a target versus actual, and then also this difference could be also plus or minus element for the company, depending how the company has performed in terms of really electricity losses. When the actual losses are less than the allowed, company can achieve some benefits and to increase the allowed revenue, and just the opposite, when the losses are higher than the allowed, the company can also achieve some negative effect. It means to decrease the allowed revenue because the loss performance has not been very good. There is also a specific incentive scheme for quality of supply. Again, this quality of supply incentive scheme refers or includes the reliability, the most important parameter of the quality of supply, the reliability, using the classical index ADSAF and so on and so forth. And there is also efficiency increase factors which are incorporated in the price control formula. This is the classical incentive regulation when the regulator has incorporated in the formula anticipated efficiency increase. And there is, of course, last point here, it is the so-called inflation term. You don't see the formula. You can see in the report the complete specification and discussion on the formula. It actually is a pretty long mathematical formulation, but you can see all the details in our report. What you see is just probably now in the slide number 16. It is not probably, it's actually definitely. It is only the formula for the electricity losses. You can just see that, automatically notice that we can have a percentage. I'll just point now this one, which is, that's actually the percentage which is really the so-called objective or really the target level of losses. And this one is really the achieved level of losses. What you can see that in both cases, these are percentages. And then what you can see here on the right side, it is really the total electricity which is really entering the distribution grid. So if there is a percentage difference from the target and the really actual losses or actual level of losses, so this percentage is multiplied with the electricity input or electricity which is entering the distribution grid to really arrive at the total number of gigawatt hours under or over performance. It means total gigawatt hours which the companies can have been better or worse than the expected target of the regulator. And then because it's a physical allowance, it means it's a gigawatt hours, we have to multiply by price, and you can see on the right, on the left side here, that's the price. PR is the price for energy losses in euro per megawatt hour. With simple terms, what the model is doing is creating a difference between the expected and the actual losses, first as a percentage, then as a gigawatt hours, and finally as money, because these gigawatt hours are multiplied by the price of energy losses. Last but not least, the model for losses is also kept in 1%, so it means the monetary implications of this model on the allowed revenue could be not more than 1% or could be not less than 1%. It means it's symmetrically kept, the company can get or really lose 1%. It is actually a cap on the incentive scheme. I want to say a couple of words now what is important. In the report again we discussed a bit longer these points, what is important to establish really good incentive schemes. Of course, the first point, it is actually really that only the economically feasible investments should be really incentivized. So it means the scheme must be actually related or must be based on the presumption that the regulator is trying to establish to establish incentives only for good investments. It means not all investment must be incentivized, but really the economically feasible investments. Of course, the important prerequisite for this model is really just to try to introduce sufficiently long period for the benefit retention. You've seen also in the previous analysis that the benefit, the payback period for this actually, and for this modeling cases, what we've done in the previous slides in the report, is that we observe a payback period under this modeling condition between 9 to 12 years. So it means this is the minimum period which actually must be guaranteed somehow in the regulatory schemes on the benefit side to make the kind of, let's say, incentives for installation of these transformers, of this equipment, sustainable for the companies. So the companies will be really preferring to go for this equipment under this modeling condition, as already said, if there is a guarantee or indication that they can retain the benefits for this period. So we're talking about sufficiently long period of benefit retention. And then again, we discussed before, now again in the context of losses, is fundamental really just to get the right trade-off between the incremental capex and loss savings. And as you remember from previous slides, we have at least two models, but two major models, how to ensure this right trade-off between capex. It means more investment, but also on the other side loss savings. It means benefits. One is the output-based regime, and one is the input-based regime. And in the output-based regime, it means we have to really define properly, actually, to include appropriate cost of allowances on losses on the output. So that means the regulator must allow this cost of losses to encourage the efficient investment. On the other side, if you're using input-based regime, so it means we want to allow the cost of equipment, then we have to really incorporate the expected loss reduction in the allowed cost. It means we're starting from the input. It means we allow the cost of the equipment, of the transformer, but as a regulator we have to properly also define and set the loss target. So it means the allowed losses. It means the losses must in long term also accommodate the expected loss reduction because of the new equipment. So these are two models. In both cases, starting from the output and trying to steer the input, or starting from the input, it means from the cost of investment, and trying to steer the output, to adjust the output. In both cases, really the incentives must be kind of, let's say, harmonized and also balanced in order to achieve the proper outcome. And now just we try to put this again in the context of the Spanish loss incentive scheme. If you go for the so-called input-based scheme, it means checking also on the input side the equipment which can provide really loss reduction. For example, in this case, different types of loss reduction transformers or efficient transformers. What this requires really a project-based assessment. It means case by case, we have to really, as a company, but also on the regulatory side, must be checked really the equipment which is really feasible to provide the expected loss reduction and to be economically, of course, feasible. In this case, must be actually really separate cost-benefit analysis for each of them. Further, if we really, of course, we have installed this transformer, we have to really roll forward the regulatory asset base. It means because the equipment will not live only 1 year, but probably many years. In this case, regulator must ensure that actually really this rolling forward is really well done. So it means that all the time the assets really remain in the regulatory asset base, and the loss targets which are really set on the output side well synchronized. It means they are reflecting the high performance of the new transformers. It's also important that if there is any adjustment because of efficiency analysis of the regulatory asset base, it must be realigned again with the loss targets. Because, as already said, the efficiency, the investment analysis, the cost-benefit analysis, what we've done shows that if the benefits are monetized and stay retained with the companies between 10 and 12 years, so the investment is really repaid under this modeling condition, as already said. So it means the payback period is between these 10-12 years, depending on the scenarios. If now, of course, we start really also taking out assets of this efficient equipment from the regulatory asset base because of different reasons, because of efficiency analysis, for example, in this case we have to be also careful what is going on with the loss targets, because the whole calculation, initial calculation, is not anymore there. We're taking also additional, money out because of the really adjustment of the regulatory asset base. And then last point again is more or less the integration point, that if we don't do if we don't do this actually measures which I discussed in the previous points, for example, this continuous synchronization between the regulatory asset base in terms of how it is recognized and what equipment is there in the regulatory asset base, and also the lost targets, in this case could be also some negative consequences for the companies. It means then the regulator must be really careful how it is done. And I think it's in general is very burdensome process, because not only because of the checks on the input side of the equipment which must be done, but also is a continuous process which probably is not congruent with the type of regulation in Spain, because it requires really guarantee that all assets which have been purchased and already allowed by the regulator and classified as efficient in this case, it means that they actually really will provide longer term benefits for the company, but also for the society. They have to be really stay absolutely for sure in the regulatory asset base. So it means they cannot be exposed to efficiency increase. It means they cannot be really taken out from the regulatory asset base. And then there is actually another scheme which is called current incentive, which is called outputs. More or less, this one is really the current incentive scheme in Spain, and in this case, it could be a bit adjusted. I think it's much more easier to continue with this scheme than with really just moving to input-based scheme. In this this scheme, we're setting the loss targets explicitly. Then we have to evaluate the loss allowances to convert them in money. And then we have to discuss probably the last point, which is the so-called caps on the incentive payments. It means, is there any need to have a cap on the incentive payment? To the first point, use of long-term average, I mean, how we have to set the loss targets, we discussed before. So it is important to have really sustainable incentives. It means sufficiently long period of time to keep the benefits from the loss reduction within the company. One approach is to use really long-term averages. It means, for example, actual loss performance of the companies from the past. One is to use really benchmark. It means comparative target, using a sample of companies to set the losses. So it means based on comparative analysis. The second point is loss evaluation. It means how we evaluating the losses. We can use traditionally the wholesale prices of electricity produced, plus some probably allowance for transportation network capacity. And the last point is shall we use cap on incentives payments? I mean, traditionally you can say there must be upper boundary, which actually can manage, can limit the risk of the company. On the other side, of course, we have to be aware that if we introduce caps, it more or less limits the incentives. So it must be actually first here what kind of preference we want, what kind of preference we have. Do we want really to limit the incentives, or do we want really to limit the risk? In both cases, we cannot really go with two targets, because if you put a cap, you limit the risk, but also limit the incentives. And now just the last point is really this, again, the conclusions. What is we've seen is that incentive regulation encourages efficiency increase in the cost reduction. What we've seen that actually the power of these incentives depends a lot on the benefit sharing arrangements and the length of regulatory period. What does it mean? Longer the regulatory period, and also higher the guarantee that the companies can keep all efficiency gains achieved during the price control period with them, then the stronger the efficiency of the incentives for efficiency increase of the companies. Because of this cost reduction incentives, the company must really also, or the regulators must put something on the quality of supply, and then economically feasible investments with positive net benefits must be really encouraged by the regulators. We've seen also in the Spanish case that we have two models how to regulate the efficiency incentives. One is with output, one is with input. Better is probably the output model, is easier and less administrative. We can use also here targets based on long-term averaging, for example, moving average, or really target just a fixed target for 10 years. And then it's really essential at the end to have sufficiently long really periods, historic period to set the targets. It means to ensure that, let's say, we have really stable targets. Also, alternatively, we can use some benchmarking models, but in this case we have the difficulties how to ensure the comparability of the companies to set the target on comparative basis. Many thanks.
This analysis has been carried out in a more comprehensive report, which is available on Leonardo Energy website in the address indicated in the introduction window. So